Hello everyone, welcome to IITN's GATE classes. So in today's video session, we are going to see the GATE 2023 solution of Electronics and Communication Engineering branch for your subject control system. So in GATE 2023, from control system, total 9 marks question was asked, out of which there was 4 2 marks question and a single 1 mark question. So before starting the video session, I would like to remind you that if you haven't subscribed to our channel, kindly do so. And if you like this video session, please press the thumbs up button and share this video with your friends. So the first question for 1 mark, it was the open loop transfer function of a unity negative feedback system G of S is given by this transfer function where K, T1 and T2 are positive constant. The phase crossover frequency in radian per second is. So G of S is given as K divided by S1 plus ST1 1 plus ST2. So now let us put S equal to J omega. So this will be K divided by J omega 1 plus J omega T1 1 plus J omega T2. So what will be the phase of this transfer function? So this is your what? This is your real number. So real number has phase 0. This is your imaginary number, but as it is in the denominator, pure imaginary number. So when this goes in the numerator, this will be minus 90 degree. For this one, it will be tan inverse of omega t1, but as this is in the denominator, when it goes in the numerator, there will be negative. So this will be tan inverse of omega t1. Similarly, for this one, it will be minus tan inverse of omega t2. Now we have to find phase crossover frequency. So what is phase crossover frequency? It is that frequency where the phase of the transfer function actually equals to minus 180 degree. So phase crossover frequency, it is that frequency where your phase of the transfer function is minus 180 degree. So if I substitute in place of omega equal to omega pc, then this will be equated to minus 180 degree. So minus 90 minus tan inverse of omega pc t1 minus tan inverse of omega pc t2 equal to minus 180 degree. So if I solve this, this will be tan inverse of omega PCT1 plus tan inverse of omega PCT2 is equal to 90 degree. So this is in the form of tan inverse of A plus tan inverse of B. So we know that tan inverse A plus tan inverse of B, I can write it as tan inverse of A plus B divided by 1 minus AB. Okay, so if I use this formula, so this will be tan inverse of omega PC T1 plus omega PC T2 divided by 1 minus omega PC square T1 T2 is equal to 90 degree. So if I bring this over here, so this will be what? Tan 90 which is infinite. So if this is infinite, that means what? Either this numerator tends to infinite or the denominator tends to 0. So this cannot go to infinite, so that means this is going to 0. So let me equate this 1 minus omega pc squared t1 t2 equal to 0. So that means what? Omega pc square is equal to 1 by t1 t2, which implies omega pc is equal to 1 by under root of t1 t2. So option A is your correct answer. So in the next question, it is asked, a closed loop system is shown in the figure where k is greater than 0 and alpha is greater than 0. The steady state error due to ramp input. So we know what? that for when your input is TUT, at that time your steady state error is given as 1 divided by kV, where kV is what? Velocity error coefficient, where kV is given by limit s tends to 0 s gs. All of this, whatever I told you, it is only valid for unity feedback system. Okay, for non-unity feedback system we cannot use this. So here you can see this is a unity feedback system, but one thing to note that rs means what? This is the Laplace transform of the input, it is alpha s square. So if you take the Laplace transform of this one, so this will be 1 by s square. Here it is alpha s square, alpha divided by s square. That means what? R of t over here is alpha. If this is alpha, that means steady state error will be alpha divided by kV, where kV is the same. So now let us try to find your kV. So kV is equal to limit s tends to 0 s dot gs. So gs is k divided by s plus 2. So s cancel. If you put the limit over here, so this comes out by k by 2. So if I substitute this in the steady state equation, so ess comes out to be alpha divided by k by 2. So this will be 2 alpha divided by k. So which option? Option A is your correct answer. So in the next question, this is a very good question. In the following block diagram, Rs and Ds are two input. The output Ys is expressed as Ys is equal to G1 SRS plus G2S DS. So G1 S and G2 S are given by. Okay. So basically here I have one system. So there is two input, one output. You have to find the overall transfer functions. Okay. For the input Rs as well as Ds. As this is LTI system, linear time invariant system, so I can calculate G1 S as Y of S by Rs when ds is equal to 0, and G2S as Y of S by ds when Rs equal to 0. Okay, I can do that. So now let us solve for G1 first. Okay. So I am solving for G1s, which is equal to Ys by Rs when ds equal to 0. So now if I put ds equal to 0 in this diagram, my block diagram, it will look something like this. So ds, it is not present. So this is G, this is Y. So this is, I have, now I am going to do what? I am going to separate this one out. Okay. Okay, so there is also H over here. So you can see what? That this is one negative feedback system. Okay, this is one negative feedback system. So for this transfer function, I will write G divided by 1 plus GH. So I can replace this whole with a single block of G divided by 1 plus GH, something like this. And this is in negative, unity negative feedback. You can see. So this is Y. This is R. So I can write Y by R is equal to G divided by 1 plus GH divided by 1 plus G, 1 plus GH. If I solve this, this will be G divided by 1 plus G plus GH. So this is basically what? This is your G1. So I have my G1. So from the option you can see option A and option D satisfies this. So directly you can eliminate B and C. Okay. So now let us check for G2. Okay. What will be G2? So in G2 basically I am going to calculate G2 is equal to Y by D when R is equal to 0. R is equal to 0. If I redraw this diagram, so it will look something like this. Okay, let me use this one only. No need to draw. See over here, there is one trick. Okay, so this is not present anymore. So now when you are solving, usually students, they get confused that how to write the expression. So it's okay. Start from the rightmost side. You can see that this is y of s. This y of s start from right and go towards left. So this y of s is basically what? You can see that it is actually multiplied with this gain gs. So write this g, open bracket. Now this g is multiplied with this input. Let this be x. Okay. So step by step, let us solve. Now what is this x? If you see, x is equal to, means you can even write this as x of s in the parenthesis, but I am avoiding. Okay. So x is equal to what? You can see that from here d is coming. Okay. From here there is some y. And from here you can see that this is basically y. Okay, this is y getting multiplied with this gain h. Okay, so d plus y, this addition y, and from here I am getting some one more signal which is actually product of y and h. Okay, so this is basically what? Y dot h. So this is, sorry, over here I have negative. Okay, so now what is this y? Okay, so I cannot take this as y. Sorry, because y is over here. So let me take this as z. Okay, so let this be z. Now what is z? If you see z, so this is not present. This is not present. So this is 0. I have considered r of s as 0. So 0, z is actually equal to what? 0. And from here I get one more signal which is actually y. So minus y. So which implies z is equal to minus y. So now start putting it over here. X is equal to d minus y of h. Okay. So now this is x. Now put this x in this expression. So y is equal to g d minus y of h. So now take this g inside. So y is equal to gd minus gy minus ghy. So substitute, bring all this y to left hand side. So take y common. 1 plus g plus gh is equal to gd. So y by d, which is actually your g2, it is equal to what? G divided by 1 plus G plus GH. So G1 and G2, both of them are same transfer function, and you can see in option A only we have that, in option B we don't have that. So option A is your correct answer. So the calculating the second part, it is a little bit tricky, but if you follow steps like that start from your rightmost side and then start moving and substitute all the signals one by one, you will get the answer. Okay. Now next question, the state equation of a second order system is given by x dot t is equal to axt, where x of 0 is the initial condition. Suppose lambda 1 and lambda 2 are two distinct eigenvalues of A, and v1 and v2 are the corresponding eigenvectors for constant alpha 1 and alpha 2. The solution x of t of the state equation is. So this is a mathematics question. So you know what, that x of t, as this is a second order system, it is given. So obviously there are two distinct eigenvalue. Okay, two distinct eigenvalue. If the system has two distinct eigenvalues, then we are going to have eigenvectors which are distinct. Okay, so x of t, I can write it as alpha 1. Okay, alpha 1 into e to the power lambda 1t v1, okay, where lambda is some constant, plus alpha 2 e to the power lambda 2t into v2. Okay, I can write it like this, where v1 and v2 are what? It is your eigenvector. So you can write this as x of t is equal to summation of I is equal to 1 to 2 e to the power, sorry, alpha I e to the power lambda it vi. So which option can you see? Option A. So this was a very simple question. Okay. So in the next question, it has been asked that this is asymptotic magnitude Bode plot of a minimum phase system is shown in the figure. The transfer function of the system is, so G is missing, G of S is equal to this, where K, Z, P, A, B and C are positive constant. The value of A plus B plus C is rounded off to the nearest integer. So you can see there is an initial slope. And what is the slope value? Minus 20 dB per decade. That means what? This is a type 1 system. So if I write the transfer function of this, let there be some constant. So I am going to write s to the power 1. Then after an initial slope of minus 20 dB per decade at omega 1, you can see at omega 1, you can see what? That there is a positive slope. Why? Sorry, this slope is 0 dB per decade. So that means what? In minus 20 dB per decade, I have added plus 20 dB per decade. So positive slope means what? There is a 0 at this corner frequency. So I am going to write this as S divided by omega 1 plus 1 into 1, because there is first order 0 at this omega 1. Next, you can see from this 0 dB per decade, the slope is changing to minus 40 dB per decade at omega 2. Means at this corner frequency, I have a second order pole. So S divided by omega 2 plus 1 square. Okay. So now if you can see from this is actually A, this is your B, this is your C. If I compare it from this transfer function, so A plus B plus C is actually equal to 4. So the answer for this question is what? 4. So with this, we end this session. If you like the session, please press the thumbs up and share this video with your friend. And if you are visiting our channel for the first time, kindly subscribe to our channel. Thank you.